Hi, in this lesson we're going to talk about Databricks clusters. So if you remember from the lesson when we talked about Spark, Spark followed an architecture that we call a leader-follower architecture. That means there is a driver node and there is a worker node. This translates back into Databricks terms to the same concept. When you create a cluster, think of it as a type of computational power that you create in order to process your data. And in the model where uh, detaching compute from storage, Databricks allows you to create varying clusters. This is primarily the main difference between the old world of working with data in data warehouses when everything is fixed. You have 4 CPUs, you have 16 gigabyte of RAM, that's it. Running all 24 by 7 all the time, you pay for it. While on the cloud, you have a luxury of creating a compute for a period of time, destroy it, then create another one and destroy it to do the job and then destroy it and so on. So in Databricks, a cluster is following what the Spark architecture have. So we have a driver node. Let's say you're going to create a cluster of 5 nodes, right? That means you have one driver node and 4 different worker nodes. We'll call it a worker node. Put it like a W like this, worker nodes. The driver is connected to these 4 nodes through the network. Now, when you run some code, you write a notebook on Databricks. This notebook will be attached to the driver node, and the driver node is responsible for spreading this notebook to all other worker nodes. So when you run the code executes on all the worker nodes together. Some operation will be executing on the driver itself, but most of the time, your code will run on the worker nodes. This is to achieve greater parallelism when you run the data. So based on that, so Databricks allows to specify certain properties when you create a compute or you create a cluster. First, you specify the number of nodes or number of worker nodes. How many workers do you need in your cluster? This is something that you need to think about when you create your cluster. Do you want a cluster with 2 nodes, like a driver and a worker, or a cluster with 100 nodes, like one driver, 99 workers? It's all up to the amount of data you wanted to process. Obviously, processing terabytes of data requires massive compute than processing gigabytes of data, than processing maybe megabytes of data. Databricks also allows you to create what we call a single node cluster, which is a driver and a worker in the same node, both together in one node. It's called single node cluster, or it's called personal compute cluster. This is the one that we use most of the time in our lessons. We use single node because we don't have much data. The Titanic data set is merely like a few kilobytes of data. You don't need just one machine. But essentially, when you create a cluster, if you have a big data to process, you need to specify how many nodes. Also, Databricks allows you to specify a range for the worker, not just a fixed number. You say, okay, I need 4 nodes, or actually my workload is varying in demand. Could be, sometimes could be gigabytes, sometimes could be terabytes. So Databricks, you can specify a range. How you do that? Through something in the cluster of Databricks called autoscaling. Autoscaling. So autoscaling is a property that you specify on the cluster. When you tick the autoscaling box, it's no longer a fixed number for the number of nodes. It's rather a range. You say, I need a number of worker nodes between 1 and 5. So Databricks will grow your cluster to 5 nodes if the workload is big, will scale it back to 1 node where the workload is small. We call this autoscaling. Also, Databricks allows you to automatically terminate the cluster if it's not in use. Databricks will charge you when you run the cluster. When you don't run the cluster, it doesn't charge you. So it makes sense that if no one is using the cluster, just terminate the cluster. We call this termination policy. So usually you need to be moderate about how long is it. Maybe if you, for personal use, maybe 1 hour or 120 minutes, 2 hours is enough. Why is that? Because when you create a cluster, it takes time to create the cluster. Because what Databricks does is when you create the cluster, Databricks under the hood will go to the cloud provider, let's say on Azure, will go to Azure and request the number of nodes that you specified. Now, depending on how busy the region are of the cloud, could be some cloud regions are not so busy, you immediately get the nodes. So maybe creating a cluster will take like 1 or 2 minutes. Some other regions are very, very busy. It could take me 5 minutes or 10 minutes in some situation to acquire this number of nodes, especially if we're talking about a big cluster, 50 nodes, for example. It takes a lot of time. So you need to be reasonable when you choose the auto-termination policy between being too small and too big. Too big means you're paying a lot of money if the cluster is idle. Too small means you need to wait more when you need to create a cluster. So you need to balance this number. 120 or 60 minutes sounds very reasonable for most of the time. Also, Databricks, when you create the cluster, allows you to select what we call DBR, Databricks Runtime. This is the engine or the operating system of Databricks itself installed on the cluster. Databricks Runtime is like where you got all the Spark code or the machine learning code, all the libraries that you will use to process the data packaged into your cluster. Databricks usually releases a DBR every 2-3 weeks, maybe every month. I think the last one now, 12, 13, 14. It's always updated. It's always recommended that you use the latest DBR. So use the latest most of the time. If you're putting your workload into production, Databricks every 6 months or so takes one version of DBR and call it LTS, long-term supported DBR. This is the one that Databricks commit to support for 2 or 3 years in the future. So if you have some troubles, if you have a bug, if you have an issue, Databricks committed to support this. While the other DBRs, usually every 6 months, the version goes out of support. So when you put things in production, make sure you always choose an LTS version. Otherwise, if you know your use case is not going to stay in production for long, but you need a feature that is in the latest release, then yeah, you can use it after trying it on development first, in pre-production, production, and so on. So that's the DBR. Databricks have 2 types of DBR, or maybe 3 types, but the most obvious one called standard. This is the one that has a Spark included. And there's an ML, machine learning. If you're going to do machine learning application, you need some libraries for machine learning. You need sklearn, you need PyTorch, you need TensorFlow, XGBoost. You need all these libraries packaged into your cluster. You don't want to install it, pip install all this library and then have a conflict of versions. No, Databricks will take care of all the infrastructure for machine learning and give it to you as a library. And in machine learning, have 2 versions or 2 flavors, one that run on GPUs and one that run on CPUs. Again, up to your needs. Some machine learning workload requires GPU processing, other requires CPU, works fine. So yeah, you can choose which one you want. But DBR is something that you always specify when you create a cluster. If you create a personal computer, think that it will pick the latest one for you, or maybe allows you to choose. But DBR is just something in mind, yet always be on the latest version of the DBR. If you go to production, maybe consider using LTS instead. Another thing is Databricks have a special version of a Spark engine or a data processing engine called Photon engine. Photon engine, think of it as a special engine of a Spark. You've got the open source Spark that runs on Spark was created using Scala, right? Photon engine is something, was created with Scala. Databricks created a Photon engine with exactly 100% compliant or covers most of the Spark APIs, but it's written in C++. And it leverages a CPU technology that speed up the processing massively. It's called SIMD, single instruction multiple data. With one single instruction to the processor, you can process multiple data at a single time and a single instruction. So this is speed up the processing way faster. You could get up, I think in some situation, 5x the number boost to your, so if you have one job that takes 5 minutes, maybe it will take 1 minute when you use Photon. Obviously Photon comes with a premium, so you're going to pay more for Databricks, but your total cost of ownership will go down. Why? Because Databricks, when you run your machine learning or your data engineering application, Databricks, it charges you on something called DBU, Databricks units. What is a DBU? It's a charging unit. Think of it like that. It's like a charging, like the minutes in your mobile. You think of your mobile, when you buy a mobile, you don't say, okay, I pay your operator like AT&T or like Vodafone or wherever, right? You say, okay, you pay $5, but you get 10 minutes. 10 minutes is your charging unit. This is how you being charged on a minutes, or if data on gigabytes of data. Databricks minutes world or data unit world is called DBU, Databricks units. It's a unit per hour. So let's say a cluster that we created could be will burn 1 DBU per hour. And Databricks publish the price of the DBU on their website. So you can go to the website, okay, say you have a cluster that will burn 1 DBU per hour and the DBU costs $1. So basically I'm going to pay $1 per hour. For every 1 hour the cluster runs, I'm going to pay $1. This is not the exact pricing, just giving an example. But DBU is the Databricks unit to charge your cluster. Now with Databricks, you have the Photon engine. This is the engine that processes it. It's a much faster engine, or much faster Spark. It's a faster Spark created by Databricks. It's optional to use. It's a tick box. You can say, okay, I need Photon for this specific workload because I wanted this workload to run super fast. So you check, I need Photon acceleration. And Databricks also allows you to specify certain things for your cluster, like your cluster policy, who can access your cluster. In Databricks, there is 2 different types of cluster. The first cluster called the interactive cluster. This is the cluster that we always create in Databricks. You go to compute, create, we call this interactive. Interactive means this is the cluster you would use to run your code, to write your code and test your code and experiment and run your code. You can share this interactive cluster with other people. So initially it creates for one user, but you can choose to create a cluster that is shared with a group of users. Let's say you are a team of 5 or team of 3, right? You can create one cluster, everyone can use the same cluster. But bear in mind, if everyone hammering the cluster with workload, the cluster will slow down. In development mode, usually maybe the best practice is to create personal compute for each one of them, and then everyone works. But if some cases it might be more cheaper actually to share the cluster among the users. The other type of cluster is called jobs cluster, and we'll come to jobs later on. But think of it as, I wrote the code, I run it, I tested it, works fine. Now I wanted to deploy the code to production. Databricks give you a cheaper version of your cluster called the jobs cluster. So you run the code on the jobs cluster, much cheaper. Almost, I think, 40% cheaper or so, allows you to run your code in a cheaper way in production. So when you run the code in a production environment, you can choose a job cluster and your code will run much cheaper. So this is at the high level, what is the Databricks cluster and how it was. Let's go back to the Databricks environment and see how we can create a cluster. So first, you go to data science and engineering. This is where you start. And then go back to compute, or click compute in here. Now this is our cluster that we created first. You just click create compute. Then this will take you to the cluster creation page. It has a name. You can change the name here. Reflects your cluster. And usually my favorite naming convention is to say, let's say this is a development cluster, and I choose the Databricks runtime version, the DBR. There is a standard, there is an ML, so it's a standard. So STD, and the version is 11.2. So 11.2. That's my naming convention, but you can choose whatever name you want, right? So let's say I'm going to pick this name. Policy, we'll come to policy later, but think of it as a way to restrict how people create clusters. If you wanted, not everyone in the team can create clusters because it's costly. And actually, if you work in a very big organization, you'll find it's really messy. If you have a team of 20, everyone can create cluster, you find your costs go like, like very big. So you wanted to limit, maybe only team leads allow, or senior people can create a cluster to other people to use. Clusters can be multi-node or a single node. I think we talked about it here. When you create a cluster, you can create a multi-node cluster, which is the default, or a cluster that has the driver and the worker at the same time in one node. It's very cheap and it's very effective as well. So you can choose which one to create here, in single node, multi-node. Access, again, do you want to share this cluster? Do you want it only one person to access the cluster, or you want it shared cluster? Right, single user and shared. There is another type called no isolation. Sure, this is kind of legacy. I think it's gonna go away in the next versions. But let's say there is two types for now. One for me only, one for me and my team. Right? Now, this is the Databricks runtime that you will choose. Like I said, this is the Databricks, think of it Databricks operating system. Which version you want to run. I always encourage people to go for the latest version most of the time. If you are going to production, maybe it's wise to use an LTS version, especially if your job is going to run for a long time. LTS means long-term supported cluster. And it's very, it's a commitment from Databricks to support this, I think for 2 years, maybe. I think recently, maybe 3 years. So your workload will continue running in production. If there is an issue, if there is a bug, if there is a feature requested, Databricks is committed to follow up and see if there is a resolution. Usually you go for the latest, try it on development, pre-production. If everything works fine, then go for production. Databricks releases a new version of the DBR, I think every 2-3 weeks you got version, and the version lasts for, I think, 6 months. So it runs for 6 months. There is another version of DBR called the machine learning. This is for data scientists who wanted to run the machine learning code. It comes pre-packaged with everything you got in the standard, plus the machine learning libraries, the famous ones. I think that it comes with sklearn, it comes with XGBoost, PyTorch. If you go to Databricks website, you can see how much Databricks, what other the libraries, so we can actually check it now. So go to Databricks ML runtime, and you can see for yourself what are the libraries that are there in this machine learning. Whether your libraries are there, and you can see, you know, what kind of libraries are included, what is supported, what is not supported, and everything that you can like all listed with the version number and everything. This is the library, top tiers libraries. You know, there's a lot of TensorFlow, sklearn, TensorPort, Spark, TensorFlow, PyTorch, MFlow. There is other libraries, HyperOpt, you know, list of all libraries with version numbers that you could use. Very, very useful if you are doing machine learning, building machine learning. This is pretty much everything you're going to use, going to be here. There is also a way you install your own library. That's maybe for advanced user, but most of the time you're going to use the ones in there. So you go back to Databricks here. So you can choose the Databricks runtime. Then this is the photon acceleration. If you wanted your workload to run faster, take this box. But look what happened here when the DBU, it increases. So this is the how many DBUs this cluster will run per hour. Without photon, it's like between 2 and 7. With photon, I think it will go between 4 and 14. A little bit higher, but also a little bit. Overall cost will be less. Why less? Because if your cluster runs for 1 hour, your cloud provider will charge you for 1 hour. But if it runs faster, the job finished not in 1 hour, finished in 30 minutes, you're going to pay less to the cloud provider. Maybe slightly more to Databricks, but the cloud provider will pay you less, so the total cost will be less, which is very, very helpful. I always recommend you to use photon acceleration. Like, keep it all the time there. It's better to have, your time saved and write or create more use cases for your business than save a little bit of cost. Worker type, this is the worker type. How big is your worker? You can choose a 14 gigabyte, 4 cores. There is a lot of variations here, and you can choose between general purpose, memory optimized, Delta cache accelerated. This is all the things that option you would want it to use. And it again, it all depending on your workload and use case. If your use cases do a lot of read and write, maybe you choose something that has a cache. Makes sense, right? You cached everything in your local SSD drive for the worker and have a fast IO. If your operations are more of memory based, like you read a lot of data, you create a lot of data frames, you join the data frames together, you process your data frame, this is a memory operation. So remember, Spark is a memory based system. Then you choose something with a memory optimized, like this one. Obviously, the cost will be different for each one, but this is something to think about. Is my operation CPU bound, or IO bound, or memory bound, or network bound? It depends a lot of factors you need to think about. If you do a lot of calculation aggregation, this is CPU bound, always use Photon. This is the worker type. The driver type, usually, most of the time, you would want it to make it similar to the worker node. So that's why there is a similar or same as worker here. So you specify the worker, automatically the driver will be the same. If you are an advanced user, maybe you can change. I usually recommend leave it the same, keep everything homogeneous, works together, and it will work. But if you do a lot of operation that requires only on the driver, and there is some operation in Spark that only runs on the driver, then you could make the driver a little bit bigger than the workers in terms of memory and CPU. Auto scalability, this is the one we talked about. You see, there is a range because you have auto scalability turned on. If you turn off auto scalability, you have a fixed number of workers. You turn it on, you have a range. Now Databricks will grow your cluster up to the maximum or go back to the minimum when the workload slows down or become less. That's auto scalability. And auto termination, usually keep it reasonable. I usually prefer maybe 120, that's fine. Maybe less, maybe more, depends on your situation and how you use the cluster. There is one thing here we didn't talk about: spot instances. Spot instances is when you create a cluster on Databricks, Databricks will go request the cluster from the cloud provider. Cloud provider have different types of VMs. One called on demand, which is I need a VM. The VM cost is $1 per hour. Okay, I'm gonna pay for the $1 and we'll take the VM for 1 hour exactly. Now the VM or the cloud provider don't have only one VM, they have maybe thousands of VM. Sometimes some of these VMs stay idle, nobody uses it. Let's say at some times customer in the cloud use 70% of the VMs, maybe 700 out of 1,000. So the cloud provider has 300 VMs staying idle. Now to incentivize people to use these VMs, they heavily discount these VMs. Heavily discount at maybe 60% or 70% in some situation. So everyone who can use VM and leverage the spot, we call it the spot. When the discount is called the spot. You can ask Databricks to create the worker as a spot. What is the danger of this? There is a caveat. So the cloud provider, they have 300 idle VM, right? They will give it to you if you pay a better price than everybody else who requested. It's like a bidding. What if you claim the VM and someone else said, okay, I need the VM for a better price? The cloud provider will give you, like, I think 1 minute notice to terminate your workload and return the VM. Databricks automatically does this in the background, so you don't have to think about it, but the drawback here is your workload will take longer. Because if the VM is requested from Databricks, Databricks will release the VM to the cloud provider and will create an on-demand VM and run your workload. So your workload will not fail, but it will take a little bit longer because of the switch between the VMs. So this is about the spot instances. So use it for wise. I usually prefer to use a spot instance when the workload is not that critical. There's no strict SLA or surface layer agreement that says this workload must complete in 10 minutes. It's a bit of like batch processing, so it can complete in 1 minute. The next batch is after 4 hours, so you can have a chance to, even if use the spot, you can release and use another on demand, so you still have time to recover. When you create the cluster will be, I'm not going to create this cluster, but I just want to show it to you. I already have a cluster here, the personal compute cluster created, right? When you go to the cluster created, there is other stuff here that appears on the top when it's actually created and running. So let's see what is this. How many notebooks attached? I didn't attach my cluster to any notebook, so I don't have a notebook now. You can see how many notebooks attached to a cluster from this page. Libraries, if you wanted to install, like I said, Databricks comes with a loaded with libraries like this ones. But if you wanted to add additional library, you can install a new library. Various sources you can install from ByBy, Maven, you know, lots of things here. Or you can upload the actual library itself. If you have a repository you work with, like ByBy, Maven, yeah. If you have the library, you can create a jar file, Python egg file, or WHL file, wheel file. You can install it in here. Event log, this is just you see when is the cluster is started, stopped, terminated, just a simple monitoring for you to see when was the cluster last started, last terminated, and so on. Spark UI, this is for people familiar with the Spark UI. This is where you track all the progress of tasks executing on the Spark, right? Driver logs, again, this is when the driver generates log file, when if you do some print, standard out, standard error, it all goes in here. Metrics, this is an interesting one. This is where you can monitor the health of your cluster. So this is the one here. I think we can see, this is the metric. Because I'm not running any workload, so I can only see the historical, but this is where my cluster was running. Memory, CPU. We'll come later to this one, see how we investigate this one. But basically it tells you, is your cluster short in memory or CPU, or does a lot of network? Then you can choose. If you find your cluster maxing out on the memory, that's a sign you should increase the cluster's memory size. Or maxing out CPU, then you increase the CPU. Just to give you a hint about what to do with your cluster. So this is pretty much it for the cluster. There is other options here. If you wanted to add configuration to your cluster, when your cluster starts, have a Spark configuration applied before even the cluster starts, like driver node starts. Very advanced things when you wanted to create a cluster. Logging, if you wanted to keep your logging configuration somewhere, you can do that here. Init script, if you wanted to run a specific shell script before your cluster starts, you can also do it here. And JDBC connectivity, if you wanted to connect your cluster from a JDBC, you can do it from here. This uses configuration, permissions, you know, all the usual security stuff. Once you create your cluster, you can see here information. This cluster will cost me 0.7 DBUs per hour. Okay, so how do you know how much this is? So you go to Databricks. I'm using Azure, right? So Azure cost. Let's see. So this will take me to Azure Databricks pricing. Then you can see how much that is, right? How much that is. So in Azure, if you create an all-purpose or interactive cluster, it will cost you 55 cents per hour for 1 DBU. My cluster is using, I think, 0.75, so multiply this. If it's, let's say it uses 1 DBU, then it will cost me 55 cents in an hour. So that's it for the clusters. There's a lot to do. You can read the documentation to know, but this is pretty much the basics that you should know about the cluster. Thanks for listening, and see you in the next lesson.